Hello everybody, I am Agrita Shukla and in this tutorial we will learn how to create our own artificial neural network using Python. So as you are seeing in the screen, this is a simple artificial neural network diagram. In this diagram there are three layers: input layer, one hidden layer and output layer. This is single layer feed forward network, and in this network the black color is showing input nodes and input layer. Hidden layer is shown by red color. There are nodes of hidden layer in red color and there are nodes of output layer in blue color. So this is simple artificial neural network where these are WIH. WIH are the weights connecting input layer to hidden layer, and WHO are the weights connecting hidden layer to output layer, and the output node is giving the output. At this layer we are getting final outputs, and the gray lines are connecting the layers as you are seeing. So now to implement the same in Python, we require two libraries called NumPy and SciPy. Okay, we are developing an artificial neural network from scratch. So to install NumPy, first what we do, we write pip install NumPy. Make sure you have Python installed on your computer. So pip install NumPy. NumPy is being installed. Installing collected packages. Successfully installed NumPy. Okay. Now please install SciPy. Ignore this error and install SciPy. So successfully installed SciPy 1.7.1. Now let's begin to write program. I am using Atom editor to write the program. First of all, import the required libraries called NumPy and SciPy. From SciPy, import special scipy.special. .special. Okay, so I am now saving the program to make it more flexible for me to check syntaxes, as syntax highlighting is only available for the program that are already saved. ANnet.py. So it is now highlighting the syntaxes. Now initialize input nodes to 3 as shown in the diagram, and hidden nodes also to 3, and output nodes to 3. Okay, now as shown in the diagram, weight connecting to hidden layer to input layer to hidden layer and hidden layer to output layer. Okay, so these weights are also required. So please first implement the weights. First create the weight connecting to input layer to hidden layer. So in this case, do numpy.random.normal. So this method will generate the weights connecting input layer to hidden layer. Okay. forward input nodes minus 0.5 comma hidden nodes input nodes. Okay, so the input to hidden nodes weights are calculated. Now calculate the weights connecting to hidden layer to output layer. Okay, so for connecting hidden layer to output layer, repeat the same function numpy dot random dot normal but change the parameters to hidden nodes and output nodes to generate the weights between hidden nodes and output nodes. Okay, done. So these are the weight generation lines. Okay, weight generation code. Next, please initialize learning rate to 0.3. You may also give learning rate to 0.5, 0.4, 0.2, but please keep in mind that as the learning rate is slow, the program generate more correct output. Okay, say for example, I am giving learning rate to LR equal to 0.3. Now please implement activation function where I am using activation function called sigmoid activation function. It can be implemented using this syntax and imported using SciPy library, scipy.special.xpid x. Okay, so this will implement the sigmoid activation function which will later be applied to hidden to each layer. Okay, so now please generate an input list. I am giving the numbers randomly 0.2, 0.3 and 0.4. Now please generate a target list where I am randomly giving some numbers as targets. Now to create inputs, let's use numpy.array and convert the same into two-dimensional array. Can convert the input list into two-dimensional array. Okay, so this line will convert the input list to two-dimensional array and save the output in inputs variable. Then targets equal to numpy dot array targets list ndmin equal to 2 dot. This will also generate a target list, two-dimensional array of target list and save it into target variable. Okay, now to calculate hidden input, take a variable hidden inputs and as shown in the diagram, to calculate hidden inputs, multiply the inputs to WIH. Okay, so to multiply, what type of multiplication is here? Dot product. Please keep in mind we will use dot product here. So numpy dot for dot product, dot for dot product, WIH inputs. Okay, so this will create the hidden inputs. So for hidden output, what we do, we apply some activation function. Okay, so activation function to hidden inputs. Okay, hidden inputs is the parameter for activation function, and this will generate the hidden outputs and save the same in hidden outputs variable. Okay, now to calculate final inputs, what we do, for final input we create a variable called final inputs, and then as discussed, do the dot product of hidden layer to output layer weights and hidden outputs. So this will calculate the final inputs. Now for final output, do something, what, apply an activation function to final inputs. Okay, so this will be the final outputs. Now let's calculate the output error. For calculating output errors, what we do, targets minus final outputs. This will be the formula of calculating output errors. Now calculate hidden errors. How to calculate it? See carefully. We do numpy dot dot, means dot product of hidden layer to output layer weights dot t and output errors. So this will calculate hidden error. Now let's update the weights. So to update the weights, first we use WHO. WHO means weight connecting hidden layer to output layer plus equal to learning rate LR multiplied by numpy dot dot, means dot product of what, output error into final outputs multiplied by 1.0 minus final outputs. Okay, outputs and then numpy dot transpose hidden outputs. Okay, so this line will generate the updated weights of hidden layer to output layer. Then for the updated weights of hidden input layer to hidden layer, what we do, plus equal to learning rate multiplied by numpy dot dot hidden errors into hidden outputs multiplied by 1.0 minus hidden outputs numpy dot transpose inputs. So this line will generate what, the weights, updated weights connecting input layer to hidden layer. Now this will calculate the input again by numpy dot array input list and dimensional 2 dot transpose. Okay, sorry, transpose na dot t is not a method for transpose. Dot t is method for. So t is same as transpose. Now calculate hidden inputs using numpy dot where the updated weights are used to calculate the hidden inputs, and then for hidden outputs do the same, that apply activation function to the hidden inputs. For hidden outputs apply activation function to hidden inputs. Okay, then for final inputs do a dot product of weight connecting output layer and hidden layer and hidden outputs, and save the same in final input variable. So this will be the final input. For final output, kindly create a variable called final outputs and apply activation function here and save it as final inputs. Okay, now what we should do, print final outputs. Okay, so here print final outputs. So this line will print the final outputs that we actually require. So now I am saving the program, opening command prompt. The libraries are successfully installed. Okay, so now open the command prompt, go to the directory, cd. Okay, now run python anat.py. Input list not defined at line 37. Okay, so see line 37. Okay, input list was there, no input list. So let's solve the error and see again. Inputs list. Okay, inputs list is inputs. Okay, not input. Okay, now again run the program and you will see the final outputs. Claps. You are successful. Thank you so much for watching the video. Hope you enjoy. If you have any problem regarding running the program, kindly write the same in comments and I will reply you as soon as possible. Thanks again for watching. Thank you.